Pat Clark with Lifting Gear Hire Corporation, and today we'll be discussing Enerpac's Synchronous lift system. We're going to show you a demonstration on how to set up and utilize the system, as well as cover some troubleshooting ideas to ensure your job runs smoothly. For openers, after you've selected the proper cylinder for your application, we want to show you the basic setups of connecting the hose from the cylinder to the cylinder control valve manifold itself. For today's purposes, we're using double acting cylinders that has two ports. A port for advancing and a port for retracting. If you'd like to see me connect these couplers a little bit closer, you can refer to our other videos on our YouTube page. Regarding the manifold, there's an upper and a lower section. If you were using only single acting cylinders, you'd only have to use and require the upper portion of the manifold. However, because we're using a double acting cylinder, we'd use the upper that is good for advancing, and then a lower section that's good for retracting the oil. Once your couplers and all of your connections are properly secure, you want to repeat this process for every point along your system. Next, we want to install the stroke sensors themselves. These are crucial components which allow you to lift your load in a synchronous fashion. Without them, or if they are damaged, you'd only be allowed to work in a manual mode. Let's take a closer look at these. On the unit itself are two heavy-duty magnets, one on the base and one on the upper portion. Ideally, we want to install the base on a fixed location below the load, while the upper magnet we want to install on the load itself. The cable is designed to have a maximum stroke of around 19.6 inches. When you've completed your application and the time comes to recoil this, you want to make sure you do so in a slow, delicate, controlled fashion. If you were to sever this cable, you'd be liable for the cost, and you'd also further delay your application itself. Regarding the shock load, these are extremely sensitive. They're also water resistant but not waterproof. So again, make sure you treat these with care. Next comes attaching the stroke sensor cables. There's a coupling on either side. You want to take the coupling with the metal connection and attach that to the stroke sensor itself. Once that connection is complete, you want to take the opposing connection that has a plastic coupling on it and attach it to the unit on the sensor input plug. To put this into perspective, we have a mock setup showing the sensor and how it will be attached. This base plate structure is just for example purposes only. It's not part of the system, nor is it a rentable item. It's just there to show a fixed point below the load. Next, we want to take our magnet on the top and attach that to our load. A good idea is to make sure that you're methodical and careful about all of your connections. You want to make sure that you have the proper hydraulic hoses matching up to whatever your assigned cylinder point is, and mirror that with your sensor input plugs as well. After you've ensured that all of your sensor cables and hydraulic connections are secured properly and in the right fashion, now comes the time to supply power to the unit. This unit runs off of 440 volts and at full load can draw up to 10 amps. It's absolutely crucial to make sure you have the proper power supply. Included with the system is the power cord adapter. On one end is the connecting point going into the unit, and on the other is the exposed wires. It'll be your responsibility to make sure you supply and to fix the proper OSHA required plug. When you receive the unit, you'll have to remove the PLC control box and monitor from the box and attach it to its mounting brackets. Once you do so, there's an electrical connection that connects the box to the electrical box in the back. You'll mirror those connections. You'll also want to make sure that you secure it properly with the straps that are included in the unit. So to turn the power on, go to the rear of the unit at the electrical box, find the red switch, and turn it clockwise. This will then power up the PLC control unit and monitor. Now all we have to do is wait for it to boot up properly. So by default, we're brought to our main menu touchscreen, which allows access to all work screens. Please note that depending on the model you're using, some functions or screens may or may not be available. This model offers work screens such as spans, alarms, preset/units, record data, networking, fast retract, perimeters, lifting, and shut down, which we'll cover later on. Starting with the perimeter screen, this area allows you to enter the capacity in pounds, what each cylinder is rated for. Plus it will allow you to enter the maximum total load and the synchronous work and stop tolerances. So for our example, we are using 100-ton or 200,000 pound capacity cylinders. You would enter 200 in the corresponding field. Notice the field is programmed to be multiplied by 1,000 pounds. You'll also want to add the total capacity of all cylinders being used in your application and fill in the max total load field. So for example, we're using 100-ton cylinders or 200,000 pound capacity cylinders. We would want to enter that total in right here. The synchro work tolerance field is to set the difference between your leading and lagging cylinder. For our example, we'll be using a 1/15 of an inch. Plus you'll want a value that would stop the process altogether if it exceeded your preferences. This is the synchro stop tolerance feature. For example, if one of the cylinders or another area of the system was malfunctioning, it would avoid an undesired movement. For our demo, we'll use a 1/4 of an inch. When we're done with the perimeters, we want to go back to our main menu. Next, from the main menu, we want to go to spans. The span screen is used by the program to calculate the position and load of cylinders. As far as the position span relates, the stroke sensor field is the maximum distance the stroke sensor is capable of extending. This has been preset by lifting gear higher and should not be altered. As mentioned earlier, our stroke sensors will extend to a maximum length of about 19.6 inches. Your field should represent that value as well. Regarding the offset position fields, most people choose not to use this option. However, at times, depending on the installation and load, the absolute position of the cylinders, as measured by the stroke sensors, are different from one another. The offset position option is used to ensure that only valid values are displayed in the absolute position box. This option creates 0 as the initial value to facilitate the work. To carry out this operation, the absolute position value must be entered for each cylinder in the offset position box. Again, you'd most likely leave these values alone as they've been preset by us. The effective area calculates the load on the cylinder. This is specific to your model cylinder that you're utilizing and will be entered as such at lifting gear higher. We will also provide you with the other specifics in regards to your model cylinders. We also ask that you not alter the pressure span or pressure transducer field, as these are also preset by us. This simply communicates the total weight by pressure to the CPL unit. From here, we'll go back to the main menu. The cylinder screen, or sometimes labeled as the lifting screen, is used to select different work modes, turn cylinders on and off, as well as display the position and load values of the cylinders. So defining each label, starting with total load, selected load, and max difference. Total load indicates the sum of the loads of all cylinders, whether they are selected or not. Selected load indicates the sum of loads on the selected and highlighted cylinders. The max difference field shows the difference between the leading and lagging cylinders. The system will work to maintain the tolerance entered in the work tolerance field in the parameters screen. The system will stop all cylinder movement if the max difference exceeds the value set in the stop tolerance field in the parameters screen. Again, for our demo, ours was set at 1/15 of an inch. Moving on to the absolute position. As long as the offset position was not altered, as mentioned earlier, this displays the actual distance the stroke sensor is extended. The relative position can be considered your working position. Specifically, it is the distance the stroke sensor is extended relative to the last position at the time of zeroing out the sensor. Relative position is used to operate and control the cylinder. Load field is the value of the load determined by the pressure measured and the cylinder size specified. Regarding cylinder selection, as demonstrated moments earlier, you can select or deselect a cylinder just simply by depressing the specific cylinder number itself. To reset the relative position, touch the red Reset Position button. This will change each cylinder's relative position value to 0 for cylinders that have been selected, i.e. those that are highlighted. Think of this as a tear out feature. The values can only be reset if the system is in the system stop mode. Addressing work modes, there's several options. There's manual, sync mode, load mode, and tilting mode. I've already selected the manual mode, which highlights the button green. This may be utilized if you need to adjust the cylinders outside of the synchronous mode or if the sensors are damaged. To select the sync mode, touch the sync mode button. The button will be highlighted when it has been activated. You want to enter the desired distance for the plunger to move by touching the delta position. In this case, we'll select 4 inches. The value can only be changed when the system is in the system stop mode. To select the load mode, touch the load mode button. The button will also be highlighted when it has been activated. Enter the final load for each cylinder to reach by touching final load. This value can also only be changed when the system is in the system stop mode. However, for today's demonstration, we won't be using this feature. And lastly is tilting mode. To find out more, contact Enerpac and/or thoroughly understand the use and care manual. For today's demonstration, we're going to be operating in the sync mode. After we're comfortable and all of our parameters have been set, now we'll go back to the main menu again. Before beginning any operation, we want to ensure that no alarms have been triggered. It's not uncommon, though, for an alarm to be activated while you've been setting up your cylinders, sensors, and perimeters within the PLC unit. Your first indicator is that the warning light/reset button has been lit. While in the main menu screen, go to the alarm page. In the interest of time and for demonstration purposes, we're going to highlight a few of the most common alarms. You can find out more about the other alarms within the use and care manual. Also, we'll show you most of these alarms on the screen for examples, but cannot produce all of them because of the circumstances will not produce themselves under these present conditions. We will start off with fail analog stroke signal. For our demonstration, we're utilizing 4 cylinders, so we produced an alarm for each one. This alert is because the system has lost connection to the stroke sensor at one of the specified cylinders, meaning the stroke sensor or stroke sensor cable is damaged. Or you may just need to reconnect your stroke sensor cable couplings. After following those instructions, you can reset the alarm by depressing the warning reset button. Power enclosure or emergency stop alarm have identical causes and solutions. The power enclosure emergency stop is located on the electrical box at the rear of the system, where the remote control emergency stop is located on the PLC unit. You would also reset these stops by twisting and pulling the button until it releases. This also would alleviate the safety line alarm. How about if the external emergency stop alarm is on? If no external emergency stop is supplied, check that the dummy plug is properly secured located above the sensor input plugs. Assuming you followed those steps properly and disengage the emergency stop, again, you would just depress the warning/reset button to clear the alarm. Regarding the stop level oil alarm, this is because the oil level has fallen below the minimum level in the oil reservoir, causing the system to shut down. You also may not have the system itself set on a level surface. You can add additional oil to the reservoir, but be careful not to overfill it. Take into account the amount of oil in the cylinders in their current position. Adding too much oil to the reservoir can cause the reservoir to overflow, creating a hazardous situation. The motor off alarm is very common but easily overlooked. This is because the pump is not running. Simply turn on the pump motor located on the PLC unit. To do this, simply depress the warning reset button to clear the alarm, and then depress the green button where it says Start Stop Motor. Moving on to the synchro alarm. This is because the difference between the leading and lagging cylinder position has exceeded the value set within the stop tolerance field in the perimeter screen. You may first check to ensure all of your stroke sensors and stroke sensor cables are anchored, secured, and properly connected. One of them may have become damaged. You can also switch the system to manual mode and adjust the cylinders that are out of tolerance by raising or lowering them accordingly. You can adjust the flow controls on the power unit to slow the lifting speed. Ideally, the lifting speed is about 1 inch per minute or even slower. Lastly, you can increase the value in the stop tolerance within the perimeter screen if the error continues to occur. Once you've followed those procedures, to clear the alarm again, depress the warning/reset button. Once all of your alarms have been cleared, now we'll go back to the main menu in preparation for lifting. As mentioned in our other hydraulic demonstration videos, it's a great idea to thoroughly cycle your system a few times to ensure that it's working properly and you remove any excess air from the system. Assuming you've already done that, now comes the point to start doing your application. We'll go to our lifting or cylinder button. Before starting your operation, we want to ensure that you have a comprehensive understanding of what each of these buttons represents and how they function. Starting with the start cycle button. All active cylinders will begin movement and will progress automatically until the delta position is completed. Cylinders will extend if the delta position is a positive number. Cylinders will retract if the delta position is a negative number. Once the delta position movement is reached, the cylinders will stop and hold position. Pressing start cycle again will begin another full delta position movement. Regarding the pause cycle, all cylinders will stop movement and hold position. The distance traveled since pressing the start cycle button will be remembered. Pressing the start cycle button again after pressing pause cycle will finish the movement to complete the delta position movement. As far as the stop cycle button, all cylinders will stop movement and hold position. The distance traveled will not be remembered. Pressing the start cycle button again after pressing stop cycle will begin another complete delta position movement. Once you've thoroughly checked all of your connections and are comfortable with your parameters, now comes the time to begin your movement. You want to start the motor and then start the cycle. Once we've achieved our final delta position in all of our cylinders, all movement will stop. This is the point where you can stop the motor. In order to reverse this procedure, we want to change our delta position from 4 to -4. We'll turn our motor on and press the start cycle button in order to begin our application. Once we're back down to near 0 delta, all movement will stop. At this point, we can turn the motor off. After your application is complete, and if you are using double-acting cylinders, you'll want to depressurize all of the cylinders and the hoses. On the top of the unit, near the pressure gauges, is a pressure release valve. You want to press this to make sure you release all of that pressure from the system. There's also a fast retract option. This allows oil to flow quickly back into the reservoir from the selected cylinders. However, it can only be used with single-acting type cylinders, not double-acting cylinders. To exercise this option, you want to select the fast retract button. Also select each cylinder for which you wish to perform this operation. Once selected, press the fast retract button and then the start cycle button. When you've completed this operation, select the stop cycle button. To turn the unit off, if your PLC unit is a Windows-based unit, you simply select the shutdown button. Confirm, and it will power down. For units that are not window-based, go to the main power switch and turn it counterclockwise. Once you've completed your application, now comes the point to dismantle the entire system. You want to do this in reverse order of how you assembled it. Remember, as I said earlier, these stroke sensors are extremely delicate. You want to make sure that you use a lot of care when you're dismantling them. Same thing goes for the cylinders, the hydraulic hoses, as well as the stroke sensor cables. We hope that you've enjoyed this video and found it helpful. In our rental fleet, we offer models of 8, 12, and 24 ports respectively, with reservoirs ranging from 40 to 60 gallons and being able to operate virtually any type cylinder. For more questions regarding our Synchronous lift system and other products that we rent, give us a call. As a reminder, the contents of this video were for informational purposes only. Please consult the manufacturer's guidelines and use and care instructions before beginning.